Guys, in this video we are going to see how to take Laplace transform of a derivative of a function. Let's say the derivative of a function is f prime of t. To find the Laplace transform of this function, what we are going to do is we are going to put this in integral 0 to infinity e power negative st. Then we plug this function right here, f prime of t. Then we integrate this one with respect to t. Okay. Now here we are going to do the integration by parts. This is going to be our u value, this is going to be our dv value. The reason is because if you look at this one, f prime of t, if you integrate this one, you will get a function back, right? Like f of t. So we can do the integration by parts. Let's write this one down. Let's write our u value, du and v dv. Okay, u is equal to e power negative st, dv is equivalent to f prime of t dt. Therefore du is going to be equivalent to derivative of this one, that's going to be negative s e power negative st dt, and if we integrate this one, that's going to give us f of t, right? And that's it. Now we can go ahead and plug it in the integration by parts equation. Integration by parts equation is integration u dv is equal to uv minus integration v du. Okay, now let's go ahead and write this one right here. U times v, that's going to be e power negative st f of t, that's going from 0 to infinity, 0 to infinity, minus integration, this integration also going from 0 to infinity, then v du, v is f of t, times du is going to be negative st. Okay, let's put the negative sign right here, s e power negative st dt. Okay, and let's write this one in a better way. We can write this one as f of t over e power st, because if you look at this one, this is e power negative st, right? So we can put it as this one. So this is going from 0 to infinity, then this minus minus, that's going to be plus. Here we are going to have plus, and this s is going to be a constant because we are integrating this one with respect to t. So this s is going to be constant, so we can move this one to the front. Okay, then we are going to have 0 to infinity e power negative st f of t dt. Okay, now from this one you can see, like when we plug infinity for this one, this is going to become 0 because we have function of t, but in the denominator we have e power st. So when we have exponent, that's going to be much larger than the function. Okay, so this is going to be divided by a big number, it means this is going to become a 0. Then when we plug 0 for this one, the bottom part is going to be e power 0. Okay, let's plug this one here, f of 0 over e power 0. Let's leave this one like this, and let's continue here. Here if you look at this one, this is a definition of a Laplace transform, e power negative st, then we plug a function dt. This is a definition of a Laplace transform, right? So instead of writing this one, I'm going to pick up the whole thing and write this one as L of ft. Okay, f of t. And finally we can write our answer as, this is e power 0 is 1, so we are going to have negative f of 0. Then this is going to be s times, instead of writing like this, we can create a new function. Let's call this function f of s. Okay, that's going to be it, right? So the derivative, finally we can write this. Let's write the final answer. The final answer is going to be L f prime of t, derivative of a certain function, like Laplace transform of a certain derivative of a function, is going to be equivalent to negative f of 0 plus s f of s. So this is the expression for the derivative of a, like Laplace transform of a derivative of a function. Okay, I hope this helps. Thanks for watching.